So today we're going to be talking about ions and isotopes, and these two things are very relevant in chemistry, especially when we're talking about atoms and the atomic structure. So in the previous video we talked about what atoms are and the basic anatomy of atoms, and adding on to this information we have two different types of atoms. First of all, ions, and second of all, isotopes. Now, first of all, talking about ions. So, what ions are? Ions are atoms that have a particular charge. So, basically, ions can be defined as atoms plus a charge. And what I mean by a charge is it can either be positive or negative. So, for example, if we have a atom of helium, and if the helium has a negative charge, this would be an ion because it has a charge. On the other hand, if it didn't have a charge and if it was just helium, this would be just considered as a neutral atom. So basically, ions are atoms with a charge. Basically, how this happens is that I've previously mentioned that electrons have a charge of negative and protons have a charge of positive. But since the number of protons cannot change in an atom without changing what type of atom it is, when the number of electrons change, ions are formed. So for example, we have nitrogen, and so we have N7 here, we have 2 electron chains, and we have 2 electrons in the first shell, and we have 1, 2, 3, 4, 5 in the second shell. And in this atom of nitrogen, if 1, 2, 3 electrons are added, this element, which was originally denoted as N, would have a -3 charge because 3 more subatomic particles of electrons were added. And since electrons have a charge of negative, it would be -3. And if these electrons weren't added and if they were subtracted, this would have a positive charge, since the negative charge of atoms are removed by 3. So that's what ions are. Next of all, talking about isotopes. And isotopes are different than ions in the sense that ions are determined by the number of electrons that an atom has, but isotopes are determined by neutrons. So ions were when atoms had different number of electrons, but isotopes are when atoms have a different number of neutrons in the atomic nucleus. So if we have, let's actually not draw for this. So for example, nitrogen at its positive state would have 7 neutrons. But let's say an isotope of nitrogen would have 6 neutrons. This would be an example. This nitrogen with 6 neutrons would be an example of an isotope of neutron. And these isotopes are a very small quantity. So these isotopes aren't very common, normally speaking. And the problem that arises when we're talking about isotopes is that although they exist in so small quantities throughout nature, they actually make it a bit more difficult to determine the mass. So since they have a different number of neutrons, this causes them to have a different atomic mass. So how do we calculate a mass of an atom if there are isotopes? Isotope types of that atom. How we do this is that if there are 80% of normal neutrons, normal atoms, and 20% of isotopes, and let's say these 80% have a mass of alpha and beta. Since there are 80% of atoms that weigh alpha, we would calculate this as alpha times 10 over 8 or 100, 80 over 100, and we add this by beta times 20%. So this would be broken down to such formula. And this is how we calculate the average mass of any atom without having to ignore the mass of isotopes. So that was it for ions and isotopes.